Namaste everyone. In this video we shall balance a chemical equation. We know how to balance chemical equations by a method called as hit and trial method. But here in this video we shall balance a chemical equation by a method called as abcde method. Sometimes the hit and trial method will be cumbersome, it will be difficult to balance a chemical equation. So especially this chemical equation, if you try to balance it by the method of hit and trial or hit and trial method, you will find it difficult to balance this chemical equations. So in such case, we have another method, an alternative method of balancing chemical equation, and we would like to call it as ABCD method of balancing chemical equation. Why is it called as ABCD method of balancing chemical equation? In this method, we would write the coefficients of the substances involved in this chemical reactions as A, B, C, D and E. Because we are using the letters A, B, C, D, E as coefficients of substances involved in this chemical reaction, this method could be called as ABCD method of balancing chemical equation. So let's see how we can use this method to balance this particular chemical equation. Before I start balancing, I would like to rewrite this copper nitrate formula as Cu 1 into 2, that is into 3 into 6 O6. So it is Cu into O6 and its coefficient I have assumed it as small letter C. Now let's see how to balance this chemical equation by this method. First, let us write down the elements that are part of this chemical equation. Now the element copper is present here, then we have hydrogen here, then we have nitrogen, then we have oxygen. So we have 4 different elements participating in this chemical equation. So now next, what should we do in this method? So here, what is the coefficient of copper? It is A. And how many copper atoms are there in the reactant side? So A into 1. There is a number of copper atoms in the reactant side. How many atoms of copper are present in the product side? C into 1. It will be C into 1, it is C. Now we should equate this. So you know that while balancing the chemical equation, we need to make the number of atoms of each element equal. So I have assumed A is equal to C here. I have taken A is equal to C. Now let's count let's see how many hydrogen atoms are there in the reactant side. So B into 1, it will be B. Here hydrogen, it is E into 2, so 2E. E into 2, I'm writing it as 2E. Nitrogen, it is B into 1, so it will be B here in the reactant side. Nitrogen, if you see here, C into 2, that is 2C plus D into 1, so plus D plus D. Then oxygen in the reactant side is B into 3, it is 3B. In the product side, so how many oxygen atoms are there? So it will be C into 6, that is 6C, plus D into 1, that is D, plus E into 1, that is E. Now let's identify the letter which is present in every equation which we have written now. So the equations which we have written are these 4 equations. If you observe, B is appearing in these 3 equations, this equation, and this equation. The letter C is appearing in this equation, and in this equation. And letter E appears in 2 equations, and letter A appears only once. Now none of the letters A, B, C, D, E are appearing in every equation. In such case, we need to choose that letter which occurs more number of times, or which occurs in more number of equations. We can, as b and c appear 3 times in these equations, in these 4 equations, we can assume a value for b, or we can assume a value for c. Let's assume a value for b, and it's better we take the value of b as 1, the value of the letter which appears most number of times as 1. Then it will be easy to find out the values of other coefficients. If you find the value of other coefficients and write them here, we would have balanced the given chemical equation. Now if b is 1, so 1 is equal to 2e. So 1 is equal to 2e, so e will be equal to 1 by 2. So we have found the value of e as well. So we know the value of b is 1. If b is 1, e will be equal to 1 by 2. Now b is present here. I shall write the value of b as 1 here as well. So 1 is equal to 2c plus d, or I would like to rewrite this as 2c plus d is equal to 1. Here there are 2 unknowns, c and d, so we cannot get the exact values of c and d by using this equation alone. B is present here, so I shall write the assumed value of b here also. 3 into 1, that is 3, plus 6c plus d. We know the value of e as 1 by 2, so I shall write 1 by 2 here. Transposing this 1 by 2 to the LHS, it becomes 3 plus 1 by 2 becomes minus 1 by 2, that is 6c plus d, or 6c plus d. 3 minus 1 by 2. 3 minus 1 by 2 can be written as 5 by 2. Now we have 2 equations in 2 variables or 2 letters here. We shall use these 2 equations and find the values of c and d. So we shall write these 2 equations here. 2c plus d is equal to 1, and the other equation is 6c plus d is equal to 5 by 2. These 2 equations are 2 linear equations in 2 variables or letters c and d. So how do we find the values of the letters? These are like pair of linear equation in 2 variables. If you are a new student of class 10, you will be learning about a method called elimination method. This elimination method will help us to find the values of the unknowns in the pair of linear equations in 2 variables. Now you shall be learning it as a part of chapter 3, pair of linear equation in 2 variables in mathematics, but here I shall briefly explain this method. In this method called elimination method, we shall eliminate one of the letters or the variables. So here it is much easier to eliminate the letter d. So how do we eliminate? We just subtract the 2 equations. When you subtract the 2 equations, 2c minus 6c will be equal to minus 4c, plus d minus d will cancel each other, it becomes 0d, will cancel each other, so 1 minus 5 by 2. So minus 4c will be equal to, this will be minus 3 by 2, or I can cancel this minus on either side of this equal sign, and c will be equal to 3. This 4 gets multiplied to 2 and it becomes 8. So the value of c is 3 by 8. Now if you know the value of c, it's very easy to find the value of a. We know a is equal to c, and just now we got the value of c as 3 by 8. So what is the value of a? A value is 3 by 8. A value is 3 by 8. Now what is that letter whose value is not found yet? It is the value of d. So if you consider this, 2c plus d is equal to 1. So 2, what is the value of c here? In place of c, I shall write 3 by 8. So 2 into 3 by 8 plus d is equal to 1. So 2 1 times, 2 4 times. So 3 by 4 plus d is equal to 1, or d is equal to 1 minus 3 by 4. So the value of d will be equal to 1 by 4. So if you examine carefully, you will see that we have found the values of all the letters or the coefficients involved in this chemical equation: a, b, c, d, e. Now we just need to write these values in their appropriate places. So a is 3 by 8. So in place of a, I shall write 3 by 8 cu, plus b value is 1. So I shall write 1 here, 1 HNO3. Then it gives rise to c. The value of c is 3 by 8, CuNO3 twice, plus the value of d is 1 by 4, so 1 by 4 NO plus EH2O. What is the value of E? The value of E is 1 by 2. So here in place of E, I shall write 1 by 2. And there is H2O, so I shall write H2O. Now if you look at the coefficients carefully, out of 5 coefficients, 4 of them are fractional coefficients. We would like to make them as a whole number. How do we make them as a whole number? We can multiply the entire equation by the biggest or the greatest denominator. So here denominators are 8, 4 and 2. If I multiply this entire equation by the greatest denominator, in this case 8, I shall get every coefficient as a whole number. So if I multiply 3 by 8 by 8, so 3 by 8 into 8, 8 and 8 will cancel each other, so I'll be left with 3 here, 3Cu. If I multiply this by 8, it will become 8HNO3. This is 8HNO3. Then if I multiply this by 8, it will be 3, 8 and 8 will cancel each other. I'll be left with 3CuNO3 twice, plus if I multiply this by 8, 8 into 1 by 4 is 8 by 4, it is 2NO, plus if I multiply this by 8, it will be 4H2O. So now what is the balanced chemical equation? So the balanced chemical equation is 3Cu plus 8HNO3 plus gives rise to 3CuNO3 twice plus 2NO plus 4H2O. So this is the balanced chemical equation. So you can just verify whether this equation is balanced or not by counting the number of atoms of each element. You will observe that the number of atoms of each element will be same on either side of this arrow mark, and we say the equation is balanced. I hope you have understood this method, ABCD method. This method can be used to balance other chemical equations as well. And now you may feel that we have consumed a lot of time to balance this chemical equation, but it will not be the case as you get used to this method, and in fact this method will be much more easier than the hit and trial method. Thank you for watching. Please subscribe, like and share these videos more, so that this videos on the concepts of mathematics, chemistry and physics will reach more students, and they'll get access to good teaching. Thanks a lot. Thank you again.